All right, good. We're going live, and we are live. Hello, everyone, and welcome to yet another DoK Talks Data on Kubernetes live stream. I believe we're now at number 89 or 90. Sometimes I lose track, but it's no exception that today is a very exciting day. We have a really cool guest who has really good energy. We're also going to learn some fun cultural facts. But before we get into that, and speaking of cool people from different countries, I hope none of you have any plans on October 12th because we have the DoK day, all right? Our second co-located event that we'll be doing in KubeCon will be on October 12th. We have all the speakers confirmed, all the schedules up there. There are a couple little changes that will still be happening, but the vast majority of things already ready to go. It is 100% free, all right? And it's 100% online, so you just got to be there. So definitely check that out and sign up as soon as you can. We've already got 700 people that have signed up, so we're expecting that to grow a lot between now and October 12th, but definitely want you to be part of the action, so please get in on that. One of the things that we talked a lot about, and literally I was just in a call talking about this, in terms of the challenges of running data on Kubernetes, the issue of operators. We've had different talks about operators. We're talking about the Cassandra operator, the Vitess operator. We've had talks with Percona about different operators, and this seems to be one of the primary solutions that's being provided for folks that want to be running stateful workloads on Kubernetes. So today, we're going to be taking a deeper look about if you want to have an operator, what's the best way to build that? What are the necessary tools to do that? In order to do that, we have an amazing expert who's Rafal Leszko, and I'm sure that was terrible pronunciation in Polish, so I apologize. He's joining us live from Krakow. Very nice to have you with us today, Rafal. How are you doing?
Hey, I'm doing well. I'm in Krakow right now. It's perfect. You know, I'm super happy to be here.
Good stuff. Can you tell us a little bit about things about Krakow, maybe things that we don't know, that we should know, places that we should visit or that we shouldn't visit?
Yeah, first of all, you should come to Krakow because it's like one of the best places in Europe and definitely the best place in Poland. So yeah, just join me here. And if you come to Krakow, just ping me and you can, we can meet for a beer or just to talk. So there are a lot of great places actually in Krakow. So either for coffee, beer, or just sightseeing. So yeah, you will enjoy it.
Very, very good. I definitely need to check it out. Definitely need to get there. And can you tell us, what are you doing in Krakow? Who are you working for? What kind of stuff are you encountering, professionally speaking, right now?
Yeah, I work in a company called Hazelcast, but it's a distributed company. It's the remote company from day one. It's not only because of COVID. They were all,
you were the real remote company.
Yeah, the real remote. Like 10 years, we did it before everyone else. So I'm actually in Krakow, but most people are all over the world. We have people, in Croatia, in Turkey, in US, in the UK. So it's just a global company. It's a small company. It's like 150 people, but it's global. It's distributed from day one.
Very, very good. And like you said, a very healthy advantage to have in the current situation that we're going through.
Yeah.
In terms of Kubernetes experience, how did you get into Kubernetes and what was your first experience with an operator?
Yeah, actually, I know everything about Kubernetes because of Hazelcast, because I'm now an expert in Kubernetes. All the integration of the Kubernetes, I'm responsible for all the integration of Kubernetes. We already have Helm-based operators. We are writing now the Go operator. We did all this work of researching what is the best way to do the operator for Hazelcast, and that is actually what I would like to share. So it's like a few months of our research, how to build an operator, and now in a nutshell, I will try to summarize it here.
Let's do it. If you want to share your screen, you can go for it. As a reminder to folks, feel free to leave your questions in the chat. We'll get them answered accordingly. But yeah, go for it.
Perfect. Let me screen share. And it was such a great introduction that, I had some slides with the introductions, but they are not needed. You already know everything.
Well, we can still take a look.
Yeah, but still take a look about. So the talk is titled "Build Your Kubernetes Operator with the Right Tool," and I will tell you about. This will be an overview of different ways how you can build the same thing. So the same tool, but the different ways how to do it. But before this talk, I'll tell you just a few words about myself. So I already told you that I work with Hazelcast. I'm a cloud native tech lead, team lead. Before Hazelcast, I worked for Google and CERN. I'm also an author of the book Continuous Delivery with Docker and Jenkins. And I do some trainings, conferences, webinars, but from time to time, it's like I do it for fun. On a daily basis, I'm doing coding. I'm a developer. So that is my main job. So I only share. So I'm a tech person. So a few words about Hazelcast. I already told you that it's a distributed company from that we have people all over the world. You might have heard about Hazelcast. It's like an in-memory data store, in-memory platform dedicated for anything when you need low latency, also for stream processing. So then you can use Hazelcast. That's actually a nice tool, so I recommend trying this.
All right.
It's not super related to this talk, but anyway, just try it. I think it's super developer friendly, so you will like it.
That is really nice. And that's not, that's a really interesting point actually, because things like developer experience, we've seen that come up, more and more about really having empathy-based interfaces and experiences that people can have. Because let's be honest, learning Kubernetes, and you as someone who's been with it for a while, it's not as necessarily the easiest thing to do in the world. So I think a little bit of empathy goes a long way.
Yes, and exactly. Kubernetes is another story. It's like Kubernetes, when you know it, you think it's easy. But I see it from people everywhere. It's that people, Kubernetes is difficult actually. Anyway, coming back to the talk. So there will be so this is the agenda for this talk. So I will do just a short introduction about operators in general. From what I understand, like there were already some talks about operators, so you probably know everything. But just to before digging into details, just to have a short overview of what the operator is, and then I will walk through all possible ways how you can build your operator. Because there are a lot of different ways how you can do it, and I will tell you what are the trade-offs, because it's always a trade-off what you choose. It's never one solution is better than other. And at the end, I will do a short summary. I encourage you to ask questions in the chat, and Bart will read it, and I will answer them.
Yeah,
it can be during the talk or after the talk. Both are fine. So the introduction. The introduction is for this talk is that you are the person who would like to build an operator and what to do, how to start. So what is an operator? So operator is an application that watches for a custom Kubernetes resource and performs some operations upon its changes. So this definition is very generic because actually the operators are very generic in nature. So you can do a lot of different things with the operator. So to make it a little more digestible, so let's focus on one example that I will use throughout this talk. So since I work for Hazelcast and since I built Kubernetes operator for the Hazelcast, I will show you all the time the example of the simplest thing you could do actually with the Hazelcast. So from the developer perspective or DevOps perspective, from the operator user perspective, you would like to specify a custom resource like this. And the operator should create a Hazelcast cluster for you. So you apply this YAML. That's all you need to know from the user perspective. And you would like your operator to take care of this and create Hazelcast cluster or update Hazelcast cluster. So the operator is this application that watches, so this Hazelcast operator will be application that watches this Hazelcast resource, and upon the changes to the resource, so any change event, it will adjust the state. It will adjust the state usually using Kubernetes API and changing something in the usually it will create other resources in Kubernetes cluster, but in general it could do anything. So in general, you can think about doing some backups. Even in some operators, you can see some integrations with the cloud providers, doing some backups to S3, etc. So it can do a bunch of different things. So this example is pretty simple, but I think it's good enough to present different approaches to writing operator. So as operator is just an application that watches for custom resource, you can actually write this application in different frameworks, different languages, because after all, it's like it's an application. Kubernetes API is a REST API, so you can basically use anything that supports REST API. So basically, any language is good. But no matter which method we will choose, there will be some common operations in common. So you will always need to implement the operator logic in some language of the choice, and that will be the different parts. But then you will almost always nowadays, it's like you will Dockerize your operator, not run it outside Kubernetes cluster, but in 99.9% cases, you will Dockerize your operator and run it on Kubernetes cluster. And then you will need to create custom resource definition. This will be the same for any operator. Then you will need to define anything you need for the permissions, so role bindings, sometimes service accounts. Then you will need to deploy your operator. It will be running on the Kubernetes, and you will finally be able to apply your custom resource. And this will be so if we take the 6 steps, so I will talk only about like the first step, because that will be the different part. All the rest actually will, no matter which method you choose, it will be the same. So with this in mind, let's jump straight into how to write this operator. And I will start from the operator SDK and using Helm. Operator SDK is actually more and more people are using this. It's a like tool from now it's an open source tool, now mainly maintained by the Red Hat engineers, which basically helps to build an operator. So it's a framework for writing operators. And one of the methods is to generate the operator from the Helm chart. So what is a Helm chart? So Helm is a package manager for Kubernetes, and it allows you to create a set of templated Kubernetes configurations, package them into a Helm chart, and then render using some parameters defined in the values YAML. So Helm is very simple because creating a Helm chart does not require any more knowledge actually than defining a standard Kubernetes configuration, because it's just kind of a templating system. So that is a good part. So if you would like to create an operator from the Helm chart, so we need to first create the Helm chart. So in our example, remember our example is very simple. It has just one parameter, which is the size of the cluster. So in our example, that would be the Helm chart. So we type Helm create chart, and then in the templates, create one file for deployment. And in the deployment, it's basically pure Kubernetes configuration. So we don't need to do anything. In a chart values YAML file, you specify all your input parameters, and that's it. So you have already Helm chart created. And now from this Helm chart, you can generate like a full-blown operator. And to do it, what you can do, you specify operator SDK init, plugins Helm, and create API, groups, and then do all these common operations. And your operator is ready. So Helm is actually, you don't need to know anything about like programming even. You just specify Kubernetes configuration, put them into template, build them as an operator, and boom, you have the operator. So I can show you like a quick demo, because it's always like better to see something. I actually created a repo. I will share the link. So this is the repo. I will share the link at the end of the talk. It will be in the slides, so don't worry about it. And here, actually, it's like, I recommend you walking through this, because this will give you like hands-on experience how to build operators. And all the methods I presented, they are here. You go operator SDK Helm, and this is like a step-by-step instruction how to build such an operator. So yeah, so if I open this in the VS Code, you can see that this is exactly what I presented on the slide. So the only code I had to write is this deployment file, which is templated Kubernetes configuration and the values YAML. All the rest was generated and the size, and that's it. A few commands and you have the operator. Yeah, I'll show you later how it's in action. But one thing to mention here is that, you know, the Helm is kind of, you know, it's like, it's very easy. It's you do it in it, you define everything with Kubernetes configuration in a declarative manner. So in SDK, they define something like operator capability levels. So what you can do with the operator with different methods. And actually Helm, you can see from this, all I would like you to see from this diagram is that Helm is limited comparing to other solutions, because you cannot do any like custom code, like, I don't know, you cannot do a backup on S3, because for this you need to write some imperative code. But in Helm, you just you only do everything with Kubernetes configurations. So Helm is easy, but it's also somehow limited. So if you need some complex operator, that will probably not be your choice. So a short summary about
just a quick question with that. With that in mind, have you worked with Kustomize?
Yeah, yes, but it's Kustomize. It's I don't know how this is related to. Do you have any like in mind?
No, just, you know, comparisons with Helm versus Kustomize, just because we had to talk about Kubernetes tools and it did come up there.
Yes, but Helm is like so I mean, Helm, you write like everything templated. Kustomize like takes another approach. Yeah, you already have your Kubernetes configuration and just would like to change some of the parts. So you, like Kustomize can interact with like a pure Kubernetes configuration. And Helm is different. You specify templated Kubernetes configuration, and then only what is templated you can change. But as far as I know, I think you cannot generate like a operator from the Kustomize. I might be wrong. Maybe they, but it's yeah. But actually, you know, it's all, you know, all these tools and in Kubernetes and operator, they're all related. I mean, operator SDK for the deployment, they use Kustomize, but it has nothing to do with generating operator from Kustomize. So yeah, if you choose like this Helm approach, so your implementation is declarative and simple, so that is good thing. And sometimes you already have a Helm chart. That was the case in Hazelcast. We already had a Helm chart, so we actually generated the operator from the Helm chart. But you have limited features, and actually everything is generated for you, so it's very simple. And yeah, I think, you know, if you know how to do it, it will take, you know, half an hour to build like an operator, which is great. Okay, but closing the thing with Helm. So another way to build an operator is to use Ansible. It's not so much used, because I can already do a spoiler that it's not so much used, because maybe I'm wrong, but I have a feeling that, you know, Ansible is a Red Hat product and they are trying to push this more than people would like to use it. But maybe I'm wrong. Maybe it's the wrong judgment. But anyway, Ansible is like it's like very powerful tool for IT automation. It's declarative in nature, so it's kind of the way you define things is declarative, but it has a lot of plugins, and you can put some declarative code inside. So it's kind of it's not as limited as Helm. And Ansible has a plugin for Kubernetes to interact with Kubernetes API, which is a good thing which you can use, and I will show you in a second how to use it. And yeah, Operator SDK supports generating operator from an Ansible from the Ansible. So it's actually it's supported. I see it's not so much used, but it's supported. So how it would look like? So if you would like to generate like operator from Ansible, you use this Operator SDK, init, plugins, Ansible, and all the things scaffolded for you, and you define an Ansible role, which if you look like this, so you can look this name start Hazelcast, and this community Kubernetes, this is the name of the plugin, Ansible plugin used. And you may have a look at this and see it looks actually very similar to Helm chart, because it's declarative manner. So again, like you define it in a very similar way, but how it works is a little differently, because there is this Ansible layer. So Helm chart really like templates these things and pass it to Kubernetes API. Here you have this community Kubernetes plugin. So there is like something in between. But it looks, if you build like an operator this way, it's also kind of good, because I mean, it's good. It's easy. I would say it's declarative. How to build it? It's the same. So if you generate, again, all the steps are exactly the same, because for example, makefile is generated by Operator SDK, no matter if you use Helm, Ansible, or as we will see later, Golang. So again, this diagram. So if you look at the diagram, like, Helm was declarative, Ansible was declarative, but Ansible actually covers all the capability levels, because Ansible is it's way more powerful tool. It's people used Ansible before all this Kubernetes hype and all this, because Ansible was very general purpose DevOps automation tool. That is why you could do a lot of things with Ansible, so it's not super limited to these first two levels. And if you choose it, your implementation will be declarative. So everything will be executed via this community Kubernetes plugin. You can cover all capability levels, and all the things are generated for you because you use Operator SDK. So it sounds like a good choice, but this is this middleware between Helm, which is super easy, and Go, which is super powerful and used. So I will show you later the stats, which method is actually used the most. Operator SDK with Go. So this is our next choice. It's the last option offered by the Operator SDK. I can already make you a spoiler that is currently the most common approach, and it's actually what we chose to build our Hazelcast operator now. But yeah, Go is like a general purpose programming language. So you can technically write any operator logic you could ever imagine, because you can write any code you would like. And what's more, like, the Kubernetes itself is written in Go, so you will never have a better Kubernetes library and Kubernetes interaction than in Golang. And that is why one of the reasons, everything in Kubernetes is built in Go, so operators usually as well. And how it looks like. So again, if to scaffold the project, you use this Operator SDK init, Operator SDK create API, and then it scaffolds you all the project. And then you no longer write like a declarative code, you write imperative code. So you really need to write all the logic. So that is like way more difficult than just Kubernetes configuration, because you have to think about all the cases. Like that is, by the way, what you see on the right. That is the input parameter specification. I can show you like this in a demo, since it's the most widely used way of building an operator. So again, if you could follow this, again, I can recommend you follow this GitHub repo when you have all this already how to generate it all. But the thing I wanted to show you is you specify your logic here in the controller, and you can already see that it's way more complex than what we've seen in case of Helm chart or in Ansible, because you really have to specify all this logic, like first fetch what is currently in Kubernetes, then get it, then check, okay, if not found, then we create it. If here we check the deployment resource already created. If not, we need to get it, we will create it. Okay, but it already exists, we don't need to create it, we need to update it. So really you need to cover, like, if size has changed, then what to do, then to update. So it's like it's another, I mean, to generate something from the Helm chart, it's like it's an easy thing to do, an easy thing to maintain. But doing this in Go is like, it's a big project. It starts like in our case we have the whole team of 4-5 people dedicated to operator right now. So it's like it's not longer like when we use the Helm chart, it was just one person doing this. So it's like you see, like that if you need complex things, but you really need to invest more if you don't go with this solution.
Really quickly, you just got a comment in the chat. Someone mentioned, thank you, Flavio, for the comment. To me, Ansible somehow relates to Bash script in terms of general tooling. Not saying that it would be my go-to when talking about building a Kubernetes operator, though.
Yes, agree. I mean, this is what I started about Ansible. I think, like, this is my private opinion, that Red Hat tries to push it because Ansible is the Red Hat tool, but I think it's not well adopted. So yeah, I agree, but you can do it. I mean, it may have some, but I probably it would not be my choice. So I agree with that.
Fair enough.
And yeah, if you have like this Golang, I already created this, build it. So yeah, you can install this. I can show you how it works. I need to go here with the Golang and make install. Make install is make file generated by the operator SDK, and it provides you all, like, it will install all the CRDs, everything in your Kubernetes cluster. So so it's kind of, yeah, see, it's like this CRD generated is created, etc., and build also everything. And then we can deploy the operator into the Kubernetes cluster, and we can see the logs of the operator when it's deployed. Yeah, if we check the logs, okay, it's yeah, as always, the demo, I see like there's some setup problem, not much. Okay, so there was something wrong with the make install. Let's try it again. Yeah, it looks configured, so it looks fine now. Let's do make undeploy. So it's like this. No, there's no, okay. Actually, there is undeploy, but it was added later than I created this project, but never mind. So let's try this again. And let's see if it works this time. It should, but yeah, there's some error. As always, live demo is always a challenging thing. But what I wanted to show you is like, normally I tried this even today, and if you walk through this, it should be fine. That's a live live demo experience.
No, but that's the whole point. I mean, that's what gives it the magic, is the fact that it may not go exactly as planned, and it's no big deal.
Yeah, I remember like I was doing some different talk, and in the old times when you could still travel for the conferences, I was doing this in Tokyo on some Go conference actually. It was a different talk, but I was doing some talk, and I don't know, in Japan it's like I think they are less somehow less, at least in my talk they were less relaxed. They were so concentrated, everybody was sitting, and I remember I was doing a demo and it suddenly failed, and suddenly everyone started to be relaxed and started to laugh, and it was like icebreaker. It was even good.
Yeah,
good
no,
thing,
that's it. Because it's like, look, I'm a human being,
Yeah,
and not everything goes.
yeah.
Not everything goes to plan. It's no big deal. So yeah, I think that's a lesson for everybody. If you really want to meet a lot of people in an event, make sure your demo doesn't work, because it's a great way to get it up.
Yeah. Anyway.
Cool.
Yeah, but it's anyway. You build this way, and it should work. and then you have the operator running.
And if it doesn't, laugh at yourself and try again. And that's it.
Yeah, exactly. So yeah, and so a short summary about the Go solution. Go solution is like you write imperative code. It's way more complex, but Go is but for bigger project it will it's worth doing this. Sometimes you need to do it because you will just not be able to implement these features using like some declarative manner. And Go is well integrated with Kubernetes, so that's why most people actually use it. Maybe one more comment here, because I mentioned operator SDK with Go, but obviously you could use, there was like not so long time ago, the most popular was actually KubeBuilder. So you may see a lot of operators out there, open source or closed source, they are using KubeBuilder. So at some point this was an alternative, but now they merged together, kind of operator SDK now is using KubeBuilder. So normally from our analysis in Hazelcast, it does not make much sense to use pure KubeBuilder because operator SDK gives you something more. So that's actually what I can already tell you, that's what we use for our operator in Hazelcast. So that's all about operator SDK, but that's not the only way you can build the operator. Another option is to use some other frameworks, not from this operator SDK, but use some other operator frameworks. And I did some research on the operators, like what are operators framework exist on the internet everywhere. And I found something like that. So like COP for Python, there is like a C# operator SDK. There is for Node.js, there is Node.js operator framework. There's Java operator SDK, and there is Operator for Rust. Maybe there are some more. But before you choose any of them for your production ready operator, so usually what you would do, you would check how popular they are. So the first thing I checked some time ago is like how many stars, GitHub stars they are. And you already see that probably C# operator is not such a good idea. Node.js, probably not as well. Java operator SDK maybe, Rust maybe, but the most promising looks this COP framework. And if we look closer at this COP framework, you can see that it was actually a fork from it was actually moved from, sorry, not a fork, it was moved from the repo that had almost 1,000 stars, so it looks the most promising. And if we look even more closer, that it was developed inside Zalando and used inside Zalando, so there is like at least some company behind it. So that could be a good choice. That's why I chose this as an example here. So COP, you implement everything in Python, but this time you don't have any scaffolding. So you need to write all these things that you got for free in Operator SDK on your own. So like a Docker file, CRD, role bindings, Operator, Hazelcast. So if you write all this file, I will show you them in a moment. Then you can finally implement the operator logic and operator in some Python file. And this is how the logic looks like. So if you are familiar with Python, you know that they have this this nice feature in Python which is called decorators. And in this framework, in the scope framework, they use this decorators thing, and it actually looks very nice. So you create like hop on create decorator, specify your custom resource, and then everything in this function is related to what happens when this CR, this Hazelcast my domain version 1 Hazelcast is created. So if you create a Hazelcast, this function is executed. And actually, if you look at this, it looks pretty good, actually. I must tell you that I really liked it because it's imperative code, so you can do anything you want, but it looks way cleaner, in my opinion, than the Go code. I can show you all the files that were in this project. So what you would have to write is, as I told you, all this like boilerplate that before was generated, now you have to write like a Docker file, your CRD, and
real quick,
yeah.
we got another question.
Yeah.
This one from Ashish, thank you. That is, what is the difference between an application deployed via Helm charts and an application deployed by an operator built using Helm charts?
Yeah, so yeah, good question. So the operator, so what is the difference like between like if you write a Helm chart and use Helm for deploying your application, and if you build an operator and use the operator? So the difference is not in the functionality, because functionality you provide, the features you provide are exactly the same. I mean, you generate it, so you cannot expect more features. But the difference will be in the tooling. I mean, if you use the Helm chart, then if I were, let's stick to this Hazelcast example. I would like to deploy Hazelcast cluster using Helm chart. So what I do Helm install Hazelcast. That's how I do the deployment. And it will deploy Hazelcast. It will print something. I have my Hazelcast deployed. So that's how you interact with your Kubernetes cluster. You do it with the Helm tool. So then if I would like to list, I can list what are my Helm deployments. Okay, yeah, I deployed Hazelcast cluster. Now, operator, on the other hand, and keep in mind that Helm, it does not install anything in your cluster. I mean, it does not, the Helm itself. Helm is a tool. It's not something that is running on your Kubernetes cluster. It's like a client tool. Now, the operator. So the operator is an application running on your Kubernetes cluster. So this is the first difference. The second one is how you interact with, how you see with the Helm, this is how I interacted with the cluster. So I created Helm, I execute Helm install Hazelcast. With the operator, how do I interact? I create a custom resource like this one. So this is what I create, this YAML, and I apply this YAML. So to do exactly the same, deploy Hazelcast cluster using Helm, I did this one. Using operator, I first need to deploy the operator into Kubernetes cluster, and then I need to use kubectl, apply this. This is actually in a different directory, but let's switch it to this conf. So I will do this kubectl apply Hazelcast. So in result, in both cases you have Hazelcast cluster. But with the operator, you interact with the cluster in a Kubernetes native way, because that's everything you do in Kubernetes, you specify a YAML and you apply it. But with Helm, it's like a different way. You interact with the cluster using Helm tool. I don't know if it answered the question, but I tried my best.
No, I think we're good. I think we're good. And the conversation will continue in the chat, so we're no problem.
Yeah, that's good. So yeah, with this COF, coming back to this COF example. So see, like everything here, like you have to write all this boilerplate code, or even how to deploy the operator itself to Kubernetes. You have to write and maintain it because it's not provided by the framework, at least at this, as it is right now, COF. Maybe COF will evolve and maybe will generate you scaffold all these files. But as of the how you write the logic of your operator, it's actually, I really like it. So you create like a deployment file, which in Python you can really nicely inline. And you have this decorator. So decorate, okay, what should happen if the CR is created, if the CR is updated, if the CR could be, we could define another one if the CR is deleted, etc. So and I think they still use it in Zalando. So I think it's if you're looking for some other choice than operator SDK, I think this is actually a good solution. Yeah, and to build it, yeah, we obviously need to build the Docker image, put the Docker image, and then we use this. We need to apply CRD, role or binding operator, and finally our CR. Before we had this hidden in a make file, so we did like make install. Short summary. So not only about COF, but generally, if you use some less popular frameworks than operator SDK, usually you will not have any scaffolding or boilerplate code generation. Usually, yeah, I would. If I were you, I would choose, if you go to this direction like framework, I would probably look for a framework that is popular or something that you would like to contribute to. That's another option. Because otherwise, you know, it's like with this less popular framework, it's you have problems, but nobody, there is not so community big enough to act upon some problems. Okay, and if you don't like any frameworks, you still can implement your operator, and I will show you in a second. It's not that crazy as it may sound. It may have some use cases, because like, you know, like operator is nothing more than an application, usually Dockerized and running in your Kubernetes cluster that does this interaction with the Kubernetes API. So actually, you could write it in anything you want. You could write the Bash script, which will become your operator. There is no limit here. So some people actually do it. I mean, they maybe not in Bash, but they Rust is becoming somehow popular, and you can write an operator. What I choose like as an example to give you some example how it could look like. Is I took it from a blog post called like I will share the link to this blog post about writing Kubernetes operator with Java and Quarkus. Java and Quarkus is somehow a good example because Quarkus make this promise that you can compile your Java application to a Docker native image, which means like that you build a Docker native image, which means that it can be very fast. It can be fast as like an this, you know, it can be as fast as application in Go or C++. So there is no this. It's like an application that is not running on JVM. So you don't have this overhead of the of this long start of the JVM. So that is why Quarkus is gaining on popularity. That is why it makes sense to do the operator this way. But what you need to know is like if you decide let's do an operator with Java and Quarkus. So what you would need to do? So again, there is obviously no boilerplate code generation. So we need to define the CRD, role or binding operator, etc. And then you finally can implement your operator logic in Java classes. And I recommend you reading this whole blog and trying this. It's actually a long blog post. It's, I think, with the 3 parts, but it explains everything. But just to give you like how it could look like. So the main part is you specify like I would like to like in Java code. I mean that you take this is the main logic. I mean to create like if already Hazelcast deployments exist, if they are empty, then we create it. If not, we will update them. But the code is much more, as you can expect. So you also need to specify client provider, like some deployment. I mean, if you like Java, you are used to it. That Java is like a boilerplate heavy language. So if you decide on doing this, you probably I will actually show you like how it looks like. I mean, this is like the Java style. The Java style is very verbose, for good and for bad. So you writing such a simple operator means writing like resource cache, which we didn't cover, but most operators, they have resource cache. In operator SDK is just generated again. You don't even see it. You specify some kind of beans which would provide you like event handlers, etc. So you generally you see, I'll just show you like the amount of the code, but you can check it again on my GitHub repo, and all the boilerplate like for input parameters, so like resource spec, and for how to create a release. So really a lot of stuff. So that is Java style, and with no framework now, nothing will help you to actually maintain it. So then you're on your own here. The good thing, as I told you, with if you use Quarkus, is that you can generate a normal Docker image, but you can also build a native Docker image, and that is actually how you would do it. And this example actually works well with the native Docker image, and it's very fast. And all of the rest stay the same. So you need to build Docker image, push it, apply all this. So why would you do it? I mean, it looks way more difficult. So why would you do write an operator in just a programming language with no frameworks? I would say like the only reason I see is like that your tool is actually already written in Java, and your interaction with the with Java would be better. Or you have like a single language in your organization, and you think it's good for your organization that if you keep a single language, it will be easier for basically organization or for your tools. Actually, I must tell you that for some time we considered writing an operator, in Hazelcast operator in Java, because Hazelcast itself is written in Java. So we could better interact with the Hazelcast cluster itself if we need some functionality. And also we had better like in the company, in Hazelcast, since Hazelcast is written in Java, we had better know-how of the Java language. So maybe it would be even faster for us. But we actually finally chose the Golang because it's just more popular, and we thought that it's easier to fight with the problems we know in Hazelcast than the problems that we don't know, like in the Kubernetes operator world. So a short summary for this talk. So finally, which tool should I use for my operator? You can look at this code snippet, at this repo or in these slides, and choose the one you like. But another approach is to see what other people do, because it's better usually to use something that other people use as well, because then it will simplify your life because you solve the same problems other people solve. And I did this exercise and checked on the Operator Hub portal, which is now called Artifact.io portal. I checked like what are the languages. So I checked the Prometheus, they actually use Golang. CubeDB, they used for the basic operator, they use Helm. For the enterprise, I guess they used Go. Datadog, they used Golang. Snyk, they used Helm chart. Jenkins, they used Go. Redis, they used Go. So you see, like already, like most people are using Go. I checked it even deeper and did some stats. What are languages used at? This is just about operators which are published in Operator Hub, which means that these are operators for some tools. I mean, not for like internal operators. And you see, like really, the vast majority is Go. There are some created in Helm, but all the rest is really small. Maybe there are some in Java, but all the rest is a really small fraction. So if you still don't know what to choose, I have some hints. So I would say if you already have a Helm chart and your software don't need any complex capability levels, then you can use Operator SDK with Helm. Super fast. If you want to create an operator quickly and don't need any complex capability levels, again, Helm is a very good choice. And actually, Operator SDK is developing this generation of the Helm operators from the Helm charts. So you can expect more and more features. Maybe they will cover some other capability levels at some point. Probably not all of them, but maybe some more.
One thing, real quick question. Someone from the audience asked, and the process of doing this, do you have any recommendations or links where people can find some awesome examples of operators?
Yeah. There is a GitHub repo called Awesome Operators, but it contains too many examples, so not recommend this one. I don't think there is one link. I can tell you when we did the research, what are some are good operators. You can check. MongoDB operator is good. ScyllaDB operator is good. You can check the TIDB operator is quite good. This three I would check from the open source ones. But I don't think there is one web page. This whole also this operators. It's a new topic. I mean, maybe it doesn't sound new because you mentioned that you already had like 3 talks about operators.
Yeah, but
so it sounds old, but it's very new in terms of the like if you look at Java projects, this is old stuff. People have agreed on some conventions, and you open a Java project, you can. But in operators, what I found is like there is no like one structure everyone follows. It's usually you need to find your way. But if I were to recommend if you would like to look at the more complex open source operator, I would name this 3: MongoDB, ScyllaDB, and TIDB.
All right.
Hint 3: if you would like to some complex feature or be flexible about future implementation, then use Go. If you would like to keep single programming language, or you need to interact with your tool is written in other language, then you either need to use some operator framework, but make sure that it's well adopted, or you would like to contribute to this. And if not, then you can still use a bare programming language. And finally, if you really don't know, then I would go with Go because that's most people use. So you will, can find a lot of questions on Stack Overflow. It will help you. I mean, the community is very active. So it's that's my advice. So this is the last slide for this talk. What I promised, so the code for this presentation, I recommend you walking through this. Just playing. It will take you, I don't know, 15 minutes to just build all these different operator styles. Then there is a link to the Operator SDK. There is a link to this blog post I promised to you, like Java plus Quarkus, which is super interesting. And the last link is to this COP framework, which is actually well built, I think. Yeah, and with this last slide, all I wanted to say more is thank you. And I don't know if there are any more questions, but I enjoyed it. I hope you also enjoyed it.
I think we all enjoyed it. This was a super good session. Like I said, this was number 89 or 90. I always lose track of which one we're on. And you have very, very good energy. You handled your demo crisis with style and class. It's not about how you fall, it's about how you land and get up. So anyway, no, but for real, I think it was really comprehensive because like you said, is that, and just because we've had talks about these things, sometimes I think we get the idea. I was talking about this earlier with somebody. Sometimes we get the idea that if you walk outside your house in Krakow right now and you walk down the street, how many people are going to be talking about Kubernetes?
Yeah.
Maybe there are certain streets in Krakow where a lot of people have, maybe. But if we take it even further, we're like, and what about operators? My next door neighbor was just having an argument about it. So I think like that sometimes in our communities, we get the feeling that, oh, this is like old news. It's like Kubernetes is still very early days for lots of people in terms of adoption. So I think a lot of these things are still being done for the first time. So to hear from someone about this is how we did it, you're not saying this is the only way to do it, but at least we know there is a way to do it. And whether it's deciding what kind of programming language to use, the different tools that are going to be on there, looking at different things and understanding the different motivations behind different tools, whether it's Helm or Ansible, who are the engineers that are working on these open source tools, it's extremely helpful. So no, you get an A+ for me. I have a couple of questions.
Sure.
Very technical question. Who is your favorite superhero out of the ones that were in your slides?
You mean this one? Let me go back to this.
This was very strong.
I don't even remember them. Yeah, where is yeah.
Okay.
No, there is only one choice for me, the Batman. It's like
wow.
Yeah.
Okay, no difficulty there. All right, so that was an easy decision.
Man.
Okay, that's an easy decision. That's fair. All right, no, I just thought it was nice to see the superheroes. Now another thing is that so we're very frequently talking in our community about writing stateful workloads on Kubernetes and the role that operators are playing in that. Do you imagine that this will be a phase that one thing that we've heard in the past is that there could eventually be one operator to rule them all, or that other sort of advancements will make it not so necessary to use an operator and that this will just be done seamlessly? What do you expect to happen in the next few years?
I think like from what this is my opinion only.
Of course.
Building operator is a big effort for the company and is a big cost. It's not like especially from the Helm chart it's easy, but if you would like to really like full-blown operator like this full life cycle and go, it's like a big effort. As I told you, we have like a team of 5 people now, and it's like in effect it costs a lot of money. So I think for the big companies, it will be still the thing. So I think like for MongoDB, this will be always the way you deploy the because they have like a big company basically.
Yeah.
So this will be the thing. For the smaller companies, I don't know. I think that some of them will die, and there will be like generic solution. You already have like, for example, meta controller. There is I forgot the name. There was some project behind building kind of meta operator. I don't know, maybe it's even called meta operator, or it was, how was it called? Oh, I forgot. It's but there's a project behind it. They tried to generalize a lot of things, and I think some projects will decide not to build like their full-blown operator, but just stick to some generic solutions, because it's just from my experience, it's expensive thing. You would not think it's expensive because you can build a demo in 1 hour, but testing this right, really focusing on every detail, that makes the cost.
Mm-hmm. So obviously a cost factor is a strong one in there to decide, because like you said, not every company has 500 engineers.
Exactly. Exactly. Yes. All the time I'm telling about like tools. If you build a tool, should you build an operator? Another thing is if you like build a production system, and you can use operator for some part of the system. You can build a microservice, but for some things, sometimes you can build an operator. So this is another story. This will be the choice of the development team, and that's probably for this. I think it will be probably not a problem, because you need to either maintain some web services or an operator. This is both fine. But for the companies like, I don't know, Couchbase, it's like operator becomes like another product, and this is like another big cost.
I think that's a good point. Yeah, even though a product sounds like, oh, I'm going to make money, but the process of creating that product is very expensive. That's a cool thing to think about. Going back to, so like I said, thinking about running stateful workloads on Kubernetes. Do you feel that this challenge right now is particularly characterized by it's a technological challenge, it's a talent challenge, it's a cost challenge? What do you think is the biggest factor that's maybe making it difficult for folks to be thinking about running stateful workloads on Kubernetes?
I don't know. It's like, I think we started from this, that Kubernetes, like you learn it and then you think it's easy. But then when I speak with the folks from my company, in our team, everybody knows Kubernetes because we work with this, but outside our team, people don't get Kubernetes. And it's like, I see it's like a big effort for them to learn. Even they are super smart people, really. We have very talented engineers in Hazelcast. Yeah. But, they are focused on the concurrency, like, how to allocate threads, etc. And for them, it's like sometimes the Kubernetes is really hard to grasp. So I think it's not so easy. But I think there is, there was this like war of the competition between different orchestrators, like should it be Docker Swarm or Apache Mesos? But I think Kubernetes won it all. Yeah. I mean, Kubernetes now is they call it like now Kubernetes is your operating system because you just interact with Kubernetes. So I think there is no going back from this. So I think the future is clear. Kubernetes will be everywhere. Yeah. This I'm sure about it. But about challenges, I think it brings a lot of challenges. But I think people will be more and more interested in Kubernetes, and they will just learn it. But we have hard times to find people like to hire, right? For example, new people.
Every company does, and so that's no secret, and that's one of the reasons why like you said, is that if operators remove the need for a bigger team through having things being automated and things of that nature, then it is going to be worth the work. But if it, you said it's those balances, those trade-offs. Another much more important fun fact was shared by one of the people in the audience, is that Batman Day is going to be this Saturday. And I don't even know what Batman Day is, but now that I have my homework very clear for me for the rest of the day, I'm going to investigate. That sounds really cool. And maybe I'll dress up as Batman on Saturday. You can do the same thing. We can all be Batman. I mean, I don't think you can be Batman too often in your life. So I think it's definitely something positive to get involved with. Last thing, Rafal, can I get you to stop sharing your screen real quickly so I can share mine?
Sure. Yes.
Just as a reminder for folks that arrived late, I already put the link to our DoK Day in KubeCon. That's on October 12th. But as we always have a tradition in our live streams, let me know, Rafal, when you can see my screen.
Yeah, sure. I can see it.
So while you were talking, we have an amazing artist, Angel, who's behind the scenes drawing what you're talking about in the moment. All right. So talking about, demo effects and things like that. Anyways, this was his visual representation of the stuff that was covered. There was a lot of stuff that was covered. So for folks that may have arrived late, we'll be sharing the slides. Don't worry about that. But what a fantastic presentation. Thank you very much, Rafal. I hope to see you in Poland. I hope to go to Poland very soon. I cannot promise that I will learn a lot of Polish between now and then, but I will do my best. Anyway, thank you very much for your time. All the folks that are attending, check out Hazelcast. Great session, and we'll be talking soon.